Hi there, Samina. This is Kelly. Let's see what we can do here. Okay, it says plot the points on a coordinate plane. Determine whether AB and CD are congruent. That word congruent, the symbol looks like this. Congruent means that they are the same length. Same length. This is the x coordinate, the y coordinate. So we're going to first start by graphing. And A is at positive 6, negative 1. So we go over 6, 1, 2, 1, 2, 3, 4, 5, 6, and then down 1. So right there we put a point. And that's coordinate A. And that's going to be 6, comma, negative 1. And then B is at 1, negative 1. So over 1, down 1. That's B. That's 1, negative 1. Now we're going to connect those. And C is at 2, negative 3. So over 2, down 1, 2, and 3. That's C. And then we have 4, negative 3. So 1, 2, 3, 4, down 1, 2, and 3. And that's D. Now, since they're completely horizontal, to find the distance, all you do is you simply count the units. Now, if a line is at a diagonal or at a slant, you use a different equation. It's called the distance equation. Let me just show you what that looks like so you can see it in the future. But we're not going to use this now because this is very easy. It's completely flat. So all you do to find A to B or B to A, same thing as just count the units. 1, 2, 3, 4, 5. So it's 5 units is for that one. And then this one, we just count 1, 2. So C to D is 2 units. So the question asks, is it the same length, or also known as congruent? And the answer is, they are not congruent because they are not, wow, sorry, my handwriting's getting a little bad here, the same length. That's number 8. Number 9 says the endpoints of a segment, JK, are negative 3, 2, and K, 9, comma 2. Find the coordinates of the midpoint M. Midpoint means middle. So we're going to start by drawing ourselves a very simple graph. If you have graph paper, this is a little easier. We're just going to estimate the positions just so you can see about where they are. This is the x coordinate, the y coordinate. So J is at negative 3, positive 2. So let's go negative 3, positive 2. So the position there is J, negative 3, positive 2. And K is at 9, positive 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 2 again. And that's K. Okay, We're looking for the midpoint between these 2 points. So first we're going to connect them to make a segment. So there's our segment. We're looking for the middle. To find the middle between any 2 points, all you do is you average the x-coordinates, average, and then you average the y-coordinates. Let me show you what I mean by average. So we come over here, make a plus sign over 2, like this, plus sign over 2. So the first one is we're going to take the x-coordinates, and we're going to add them and divide by 2. And then we take our y-coordinates, and you add them and divide by 2. That's what average means. We're going to average the x-coordinates, and we average the y-coordinates. -3 plus 9 is 6 divided by 2. 2 plus 2 is 4 divided by 2. 6 divided by 2 is 3. 4 divided by 2 is 4. And this is our midpoint, M. Let's see if it works. What's nice is when you graph this, it actually looks like the answer. So we come over here, and it's over 3. 1, 2, 3, up to 1, 2. There is our midpoint, M. And if you look very closely, especially if you did this on graph paper, these 2 pieces are exactly the same. And to make note of that, we do these little, they're called hatch marks. Those hatch marks tell me the distance from here to here is the same as there to there, which means this point M is a midpoint. All right, question number 10. It wants us to find both the perimeter and the area of the figure shown. Perimeter and area. Let's just trace what this is going to look like. Perimeter means to go all the way around and just add up those side lengths. Area means I want to find the inside area, like finding the area of a carpet in a room. To do both of these, you need all the lengths of the triangle. So it's important to get all the lengths. 2 of the lengths are very easy. This length right here, because it's vertical, you can simply count the units. 1, 2, 3. That's 3 units. I'm going from +1 down to -2. That's 3 units. This way, we just 1, 2, 3, 4. We're going from -2 to +2, therefore that's 4 units. Now what makes this a little easier is the fact that you have a right angle here. So if you have 2 sides of a right triangle, we're going to find the distance right between these 2 points. So to do that, I'm going to use what's called the distance equation. The distance equation, we're going to put it underneath, looks like this. The second point minus the first point x squared, the second y point minus the first y point squared. So in this case, usually we read graphs from left to right, just like you read the English language. It really doesn't matter which one's second and first. What does matter is the direction you start, you finish. Let me show you what I mean. I'm going to go from this x to that x. Notice the direction I'm going. We're going to draw a blank equation. So I'm going to go from 2 down -2 down to +2. And then I go my y's. Notice I do a little arrow to help me with the direction. That's 1 and -2. We're going to do the math here. -2 minus 2 is -4 squared. 1 minus -2, double negative makes a positive. So that's 3 squared, and we're doing this under the square root sign. This is -4 times -4 plus 3 times 3. That's what square means. -4 times -4, that's 16 plus 9, 25, and the answer is 5. So all of that gives us this distance right here. Just going to erase this and make it a little cleaner for you to see. This distance from here to here is 5 units. So the perimeter, to find the perimeter, we simply add. You walk it around. That's going to be 3 plus 4 plus 5. Our perimeter is 12 units. Now, to find the area, I'm going to bring this over here. Let me redraw the triangle. This is 3, this is 4, this is 5. We want to find the area of a triangle. I need to do a little background here. All right, the area of a triangle, there's different kinds of triangles. You have what's called like what you would consider a normal triangle, like this. And then this is specifically a right triangle. Now the area of both these triangles is going to be the length of the base times the height divided by 2. What's super important to understand is when you see the word height, it always implies a right angle. So in this triangle, that would be the base, and that would be the height, because it implies you have a right angle. But when you have a right triangle, the base and the height are actually the legs of a right triangle. So in this triangle, this length would be the base, this would be the height. In this triangle, that would be the base, and that would be the height. I could even rotate this right triangle like this. Do you see how the right angle has now moved? but we would still call this the base and this the height. So right here, for this triangle that you want to find the area of, let's write our area equals the length of the base times the height over 2. Our base in this case is 4. Our height is 3. I did not choose 5 because you have to, base and height always implies a right angle. So I use the 2 pieces connected to the right angle. So it's 4 times 3 divided by 2. So it's going to be 6 units, and because it's area, we say 6 units squared. For perimeter, we just say 12 units, because it's only dealing with length. For area, we have to say 6 units squared. The last one here, it says identify the segment bisector of AB. So let's just trace AB. And then you're going to find the length of AB. See, notice it doesn't have a segment here. When we say AB, we're talking about the segment, the physical segment itself, which I just traced. When we say AB without that, it's asking for the distance or length. So notice it says AB. That means we want to find that length. So as I said before, these hatch marks mean these 2 pieces are equal. So A to M is 15. That means M to B must also be 15. If you put a bracket here from A to B, you now see the distance A to B is going to be 30. I hope this was helpful. Samina, please feel free to send me additional problems in the future. I'd be happy to help you. God is good to me, and He wants me to be good to others. Hudafis.